I am Javier Lopez. I work with Altman Plant. I have almost 6 years we work with Altman Plant. It's not my facility. Actually, it is this facility is cactus and succulent. I come from Fallbrook facility, which is totally different with the system that we have in there. Jerry asked me, talk about the what is it, our experience in working with recycled water. So this is the second facility that we have a recycled water. The main or the big one facility is in Lake Matthews. I don't know if you have the opportunity to be in there. It is 450 acre in production. So we're moving almost 2 million gallons per day. This is a small one. This is moving around in the peak of the season. We're moving around 90,000 gallons per day. Now in the low season, we're moving around 50,000 gallons per day. And so the system that we work for us is the chlorine dioxide system. We're working really close with AquaPulse, which is the company that we are being, completely confident in all this year how the water and how the treated also our water, because it's so many things about when we recycle water, because we're moving pathogen, we're moving chemical, we're moving fertilizers. And so part of the Altman plants, how we have the experience with the water is to completely monitoring. So every 3 months, for example, every 3 months we send them to the lab water samples to see what is the more chemical residue that we have in the water. So we find that the Paclo bonsai, so when people will use the Paclo, is the one with the strong chemical. It is resistancy for the chlorine dioxide. The other is the herbicide, glyphosate, which is Roundup, and the other is Indaciflan, which is Marengo. So these 3 chemicals, we send samples every 3 months to see what is the part per billion, because when we find it, around 0.5 part per billion is affecting our plants. And so that is the way we know exactly what we bring in when we recycle water. So the way to see the rate of how we set the rate of the chlorine dioxide is depend on what is the you want to treat it. The chlorine dioxide system is needed time. It needed time to be in contact with the water to kill pathogens. And so it is not only the injection. So we need it, if you see a couple times here, and also you're gonna see a couple times at the top of the hill, is because we have around 2 minutes to rest the water just to kill more pathogen. And the more time we have a water rest in there, is more timing to kill the pathogens. And so that is the way we, moving our water. This facility, we collected the whole water like gravity is coming this pump. This pump is around 300,000 gallons. So, and then we pump in the water to this tank because the volume that we're moving is so high. And so we have to rest our water here that is working in the series is working with the flow. Anytime we get 1 inch low, we started to the pump and automatically, fill this tank. And then coming from here and then get that treated for the chlorine dioxide. And so I don't know, Aaron, if you explain a little bit how it works, the chlorine dioxide, because we have different systems and they can explain better for me.
So my name is Aaron and I work with AquaPulse Chemicals. We're the ones that design and install the equipment you see behind us. So the way that it works is it comes from the pond through the holding tanks, and then the pump we hear cycling up in the back, and there's a secondary pump is pulling from the tanks and sending it to 2 different locations on the property. We measure that flow rate with a flow meter, and we inject the chlorine proportional to that flow rate. So the more water they use, the pumps will speed up and slow down. And our goal is to maintain a part per million in that water, regardless if it's 20 gallons a minute or 150 gallons a minute. Our goal is to maintain about 0.7 to 0.9 parts per million at this location. Lake Matthews, it's a little bit higher, and I think they might have a higher organic load up there than they have here, so we have to run a little higher. What we're ultimately looking for is to find a residual. We can go out to any one of the sprinklers, pull a sample of that water, and we want to see some bit of residual, whether it's 0.1 or 0.2. By the time it goes through the tanks, gets all the way out to the sprinkler head, if you still have a residual, it's had to kill everything in the water and still have enough chlorine dioxide left over to leave you a residual to give you that number. So what the system's doing right now is it's injecting based on our flow rates. Chlorine dioxide is kind of a unique chemistry. It uses 3 chemicals that blend together to fill up an on-site batch tank. It's not a product you can make in a barrel, ship it across the country, they open it and they can use it. It basically has about a 24 to 48 hour shelf life before it starts to deteriorate. So we have a small batch tank around 20 gallons that refills itself as the pumps are using it. It may deteriorate 5% over that 48 hours, but over a week's time, if you had a barrel, it would almost just be water at that point. The unique thing with chlorine dioxide is there is no byproduct. Once it does its job, there's no trihalomethanes left behind. There's very little salt that's left behind just in the process of making chlorine dioxide. We can run it at lower parts per million than we would chlorine because it's much more effective. It's actually a dissolved gas, so it's more effective at reacting with the bacteria and doesn't need as much contact time as normal chlorine does. The other benefit is it works in any pH. It's just as effective at 4 pH as it is 10 pH, not like chlorine where you have to have it around that 6.5, 7 to really get the effectiveness out of it. It doesn't care what the pH of that water is. So if you guys want to step up, I can kind of just run over what we're looking at with the sensors and the injection equipment, and then I can have Loys answer any questions that you guys might have on the technical side of it. So I don't know, it's kind of a tight fit in here, but I can jam a couple people in here. And behind us we have a chlorine dioxide generator that we use at this greenhouse, which is Altman Plants. We'll start out by going over the chemistry. So chlorine dioxide is generated using 3 baseline chemicals. So we're using sodium hypochlorite, which is this one at 12.5%. We use hydrochloric acid at 15%, and we use chlorite at 25%. Those chemicals are blended together through this device, which is our chlorine dioxide generator. It uses an induction style system where when the water's flowing over the adductor, it draws the chemistry in under vacuum and fills up our batch tank. Once the batch tank has filled itself, our metering pumps will then use it out of the batch tank, and this is basically just a tank that refills itself over and over again. The system is monitored online, so we are able to know how much is in this unit. We can look at it anytime, see if they're having an issue. If they run out of chemical, it will send us out an alert when it gets down to about 25%, so we still have time to do something about it. It takes them about 1 day to go through 20 gallons of product, so this is roughly making 1 batch tank every day. The metering pumps are tied into this system using flow meters. We have 2 lines here, basically line A and line B. A flow meter is monitoring the water flow and drives these pumps proportionally, meaning it speeds them up and slows them down as their demand also increases and decreases. We monitor how much chemistry we're putting in the water with our 2 sensors. This is measuring chlorine dioxide in parts per million, and we have a target of about 0.5 to 0.7 parts per million. Based on what these sensors are telling us, it allows this system to run the way it should. If the readings get too high, it will actually stop the pumps and send us an alert or send them an alert saying, hey, you're out of spec on this thing, it's not working. If the readings are too low and the pumping system is working, it will also alert them and say, hey, you're having an issue. At that point, we can determine, do they run out of chemicals? Is the generator not functioning correctly? We have a visual alarm on this one, but being where it's located, it doesn't really do us any good. So we have it tied to the internet, which will send out text message alerts as well as emails. This will also send us a daily data log of what's been going on the last 24 hours. It reports how many gallons of water per minute, total water usage, and what the parts per million are every 5 minutes. So you get a 5-minute stamp, and then it sends that report out every 24 hours. You can put that in a file and basically create spreadsheets, have a monthly readout, and kind of, meter what you guys are doing. You can also see what times of year you use more or less water. We know what kind of chemicals you use. Obviously in the summertime when everything's hot, you're going to use more chemical. In the wintertime, that slows down. That helps us kind of monitor inventory and plan for chemical delivery. So that's basically the system. They're very hassle-free. We come out on a monthly service call. We make sure the pumps are pumping. We can rebuild them if needed. We clean and calibrate the sensors. We verify that our generator is making the proper amount of chlorine dioxide, and we verify our inventory, and then we fill out a service report and turn that into the customer. That's it.
So I would say around 10 years ago, we used the ozone system. We find out the system was not enough, and also it's really expensive for us. It is also maintenance. So when we decide what kind of water treatment we have to install it after the ozone system, we make our research. And so chlorine dioxide was one of the best, because company like AquaPulse, we work with us every week. They have a rep, and so checking all the rate is fine, if we will have the tank, full tank ready, if we order. And so this kind of job, relationship we have with the AquaPulse is help us to be more confident with the water. Because when we use the water for the plant, you have to make sure the water is confident to irrigate it, because you're gonna pay a lot of things if your water is not in the good quality.
The idea of treating water on the fly is that by the time that this water makes its way to that sprinkler, that chemical has treated it.
And
right?
chlorine dioxide is very soluble in water. We have systems where we inject it, and 10 feet away, it's perfectly mixed into the water. And we know that because we can we have a sensor that's monitoring this water, and you would think with it dosing chemical, you'd see it go high, low, high, low. 10 feet down the pipe, it's just very consistent because it mixes in with that water very rapidly. But we just have the benefit that it's got to go a long way, and that gives us more contact time. Not only is it traveling a long distance, but sits in tanks before it even gets out to the sprinkler heads. Right. The other benefit with chlorine dioxide over a lot of other sanitizers, chlorine dioxide is going to break down biofilm within all the piping system, whereas chlorine won't do that. Chlorine will it will kill what it comes in contact with. So if you have a 4-inch pipe with a 1/4-inch layer of biofilm, it's going to keep that layer, the outer layer, at bay. But the second you run out of chemical, that thing reintroduces its biofilm back into that water. If you were to cut one of these pipes open, you're going to find they're going to be clean and white on the inside. Now, it takes time on an old system to finally get it all out, but they've had it on for a long time, and you cut into these pipes and there's no biofilm within them, especially if you're using emitters and drippers. There's a lot of labor that's spent in cleaning those emitters out. That remedies that solution as well. So once you get the biofilm under control, then it takes very little treatment. So we either do it a couple ways. We'll start a very slow treatment over a long period of time, take it off very slowly so we don't get this big slugging. Or if it's set up correctly, or if it's set up to where we can do a very high dosage over one day, like 500 parts per million, let it soak for 4 hours, flush all that out, do another 500 ppm, and flush it out, we can jump ahead and basically clean all the biofilm out within.
That's not gonna happen.
Yeah, so this is not set up for it. But like in a greenhouse operation where you could fill up one empty greenhouse, let it sit, and then flush that one out, and then move to the next one. Right. But this one, we just start out slow, and you can see it. We'll be treating here. I measure over here. I'm getting 1/2 part per million. I go to my first dripper, I don't see anything. And then 2 days later, I start seeing 0.1. And then a week later, I start seeing 0.4. And then as I move farther out the field, eventually it's all going to get up to the thing because we've taken care of all the biofilm. We're going to get the same treatment here as we do up at the top. So.